let's do a quick recap. The law of inertia, Newton's first law, states that an object will maintain its current state unless the net force changes. So essentially it's saying if an object is in equilibrium, remember we define that as a net force of 0, it will keep doing what it's doing. So final velocity would be the initial velocity in that case. That's our law of inertia. And the second law handles what happens when the net force is not 0. Again, when we have a net force, first law implies that if the net force is 0, we maintain our motion. So if the net force isn't 0, we must change our motion. So if the net force is not 0, we must have an acceleration that is not 0 as well. And I feel like it's kind of, I feel like the first law may be misnamed. I almost feel like the second law should be called the law of inertia because it describes what determines the amount of acceleration. Second law says that the acceleration is proportional. So it's like an infinity symbol, but somebody cut off the end. Acceleration is proportional to the net force exerted on the object, and the acceleration is proportional to the inverse of the mass. Or rather, I should say it's inversely proportional to the object's inertia. It's just that when an object is moving from point A to point B, so if we if we can say it's translating, so it's translational inertia. That translational inertia is just the mass of the object. And there's no constants or coefficients involved, so second law can just be written as the net force exerted on the object over the mass of the object. So it's really filling in the rest of what first law didn't take care of. So first law handles everything in equilibrium, saying that the acceleration here would be 0. Second law says when the net force isn't 0, the acceleration will be proportional to the net force, inversely proportional to the mass. When it comes to solving forces problems, you can always use this relationship in conjunction with the definition of net force. So remember, the definition of net force is that it is the vector sum of all the forces acting on the object. And keep in mind, you can find the net force just like you would any vector sum, like a resultant displacement or resultant velocity. You're going to resolve anything at a weird angle. You're going to add your x's and your y's, and you'll draw a new triangle using the total x and the total y components. Either way, this means we always have a system of equations that we can use to solve any given force problem. So we're going to rearrange this one. So F, or net force, equals ma, and net force is equal to the vector sum. So when you don't know one side, chances are you know the other and can figure everything out. And you'll notice second law even covers law of inertia. If the net force is 0, the acceleration must be 0 for a mass. So I don't even know why we have the first law, other than to describe what inertia is. It's our resistance to that change in motion. So that this covers my tip for solving forces problems. Remember, you always have two force equations. One is second law, the other one is the definition of net force. So when you don't know enough for one, try the other. Okay. So I gave one of my tips for solving forces problems, and I said that's to remember there are two formulas that we can use at any given time. We have second law, and we have the definition of net force. But I neglected to tell you something huge here. Newton's second law kind of leaves out that the force, the direction of the net force, is the same as the direction of the acceleration. Or rather, I guess the acceleration's direction is the same as the net force. So my second tip for you is whichever way the acceleration is going, I don't care, make that direction positive, because this will ensure that your net force is positive. Another way to look at it, your net force is always going to be along one of the whichever direction has more components or more forces or stronger forces. And so I think it's just easier to conceptualize the stronger side as the positive side. So that's my second tip, is whatever direction the acceleration is, make that positive, so your net force will be positive as well.